In the previous video on mapping diagrams, we briefly mentioned the words domain and range. These are really key terms when dealing with functions. And in their simplest form, a domain is the set of things, or the usually numbers, which we input into our function. This is normally given to us. The range is a set of things, or numbers, which we get out of our function, given the domain. So the domain is given to us, we can put those numbers in, and we work out the range of a function. This also works for mappings, not just for functions. Remember, the difference between a mapping and a function is a function has to be one-to-one or many-to-one. If you can't remember that, then have a look at the mapping diagrams video. So our function might not necessarily be a numerical one. So our mapping in this case might be that we make dinner. Okay, so we're going to make dinner, that's our function. And the domain, the things that we can input into our mapping, are the ingredients we have at home, whatever ingredients they are, and the range of things we can make are the meals that we can make with the given ingredients. So if we had some bread and cheese, we might be able to put those in, and out we would get a sandwich. Okay. So let's have a look at this in a more numerical sense. So in this one we're going to have the function is going to be 2x plus 1. The domain is given to us, and in this case the domain is going to be the numbers 1, 2, 5 and 8. So to work out the range, we have to work out the function for each of the numbers in the domain. So if we call our function f of x, then we need to work out f of 1, which is 2 times 1 plus 1 is equal to 3. So we put that number in our range, 3. We need to work out f of 2, which is 2 times 2 plus 1, which is 5. So we put 5 into our range. We need to work out f of, next number is 5. So f of 5 is 2 times 5 plus 1 equals 11. So we put 11 into our range. And finally, we need to work out f of 8, which is 2 times 8 plus 1, which is equal to 17. So we put 17 into our range. So given the domain 1, 2, 5 and 8, we put each of those numbers into the function, and the numbers we get out become our range. So let's have a look at another example. This time our function is going to be x plus 2, and we're going to call it g of x equals x plus 2. This time our domain is going to be minus 1, 0, 1, 2, 3, and when we calculate each of these in our range, we get minus 1 plus 2 gives us 1, 0 plus 2 gives us 2, 1 plus 2 gives us 3, 2 plus 2 gives us 4, and finally 3 plus 2 gives us 5. For the next function, we've got 2x minus 2. This time our domain is going to be slightly different. Our domain this time is not going to be a set of numbers given to us, it's going to be a set of all numbers x such that x is bigger than or equal to minus 2 and x belongs to z. Now we need to remember what this notation means. The colon is such that the inequality says that x is bigger than minus 2, and this last bit says that x is an integer. The E symbol means belongs to, and the funny Z is a symbol for integers. And remember, integer means any whole number. So our domain is all whole numbers bigger than minus 2. And the way we work out what the range is now is we think about the values we have. We can't do every single one because there's an infinitely many of them, because it's every whole number bigger than minus 2. So we're going to start off with the limit of our domain, the smallest number that can go into our domain, which is f of minus 2. Okay? This is, we've called our function f. So f of minus 2 is 2 times minus 2, then subtract 2, which is equal to minus 4 minus 6. So we get minus 6 out. Now let's try the next whole number, would be f of minus 1. We get 2 times minus 1, minus 2. This time we get minus 4. If we keep doing this, we get f of 0. Gives us 2 times 0 minus 2 equals minus 2. F of 1 equals 2 times 1 minus 2 equals 0. And at this point we notice a pattern. We notice that we're getting the even numbers, whole numbers, bigger than or equal to minus 6. So our range is the set. We use a different letter for the range. We use y for the set. So it's the range of values y such that y is bigger than or equal to minus 6 and y is a whole number or an integer. So the way we did that was we started at the smallest possible value we could put in our domain, minus 2, and then looked for a pattern as we increased the numbers that we put in. The next function we're going to look at is x squared, and this time the domain is going to be x such that x belongs to R, and R is the set of real numbers. That's all possible numbers, decimals, fractions and whole numbers. So once again we have to consider some possibilities, but we can't test every possibility because we have infinitely many numbers available to us. So we start off by thinking about what f of 0 would be, and that would be 0. If we did f of minus 1, we would get minus 1 squared, which is 1. If we were to do f of 1, we would get 1 squared, which is 1. If we were to do f of 2, we'd get 2 squared, which is 4. If we were to do f of minus 2, we'd get minus 2 squared, which is also 4. And at this point, we notice that no matter what number we put in, whether it is negative or positive, we always get a positive answer. And that's the key to this one. The answer to this one, the range for x squared, is all values y such that y is bigger than or equal to 0 and y is a real number. So that's all positive numbers, decimals, fractions, whole numbers. As long as they're positive, they are in our range. Finally, we're going to look at some graphs of functions and work out the domain and range from the graph of a function. So in this graph, we have that the maximum point up here is 3, 4. The domain on a graph is all the possible values that x can take. So all the values of x that will give us somewhere on the graph. So if we went down from there, we would hit the graph. If we went up, we would hit the graph. If we went down from there, we would hit the graph. And if we kept going, left or right, we would hit the graph. So the domain is the set x such that x is any number, any real number. The range, however, is the numbers we get on the y-axis. So it's the possible numbers we can get going along this way. So we can get numbers there, we can get numbers there, we can get numbers there, we can get no numbers just above that. We touch the point there, but above that point we don't hit the graph. So the range is all the ones where the horizontal lines from the y-axis hit the graph at some point, and that is all values less than the point there. And the point there's y value is 4. So it's y such that y is less than or equal to 4 and y is a real number. Two more graph examples to have a look at. In this one, first thing we notice is that we have this dot here. So our graph has stopped at that point. And much like inequalities, a filled in dot means we include that point. So first of all, our domain is all the values we can get to from x. So from x, if we were to go up, we'd hit it. From there, we'd hit it. From there, we'd hit it. From there. But from there, because the graph stopped at that point, we don't hit it. So the smallest x value is in that gap there. The smallest x value is -4. So our domain is all values x such that x is bigger than or equal to -4 and x belongs to the real numbers. Notice it is bigger than or equal to because the dot at the end was a solid dot. Now for our range, we look at what values we get going from the y-axis. So from here we hit the graph. If we go up, we will keep hitting the graph because the graph's going up there. We hit the graph there, we hit the graph there, but there we do not hit the graph. So the lowest point we hit the graph is at that minimum point there, which is 4 minus 4. So the range is all values y. They have to be above the y value there, which is -4. So y is bigger than or equal to -4. And again, y belongs to the real numbers. In the final example, we have a line that is stopped at both ends. At this end we have a solid circle, so it includes the point. At this end we have a hollow circle, so it doesn't include the point. In much the same way, our domain is all the values of x that will hit the line. So we hit the line, we hit the line, we hit the line, but over here we do not hit the line, and over here we do not hit the line because it stops. So our domain is all the values x such that x is bigger than -1, there's the -1 there, but less than 4. So it's -1, x is bigger than or equal to that because the dot was filled in, but it is less than 4 because the dot was hollow, and x is once again a real number. For the range, we go across, there we hit, down here we do not hit, and up here we do not hit. This time we have -2 is the lowest y value we hit, and 3 is the biggest y value we hit, so we have y such that y is bigger than or equal to minus 2, because we have the filled in dot that end, and less than 3, and finally y is in the real numbers. So y can take any number between minus 2 and 3, given that we can put in any number between minus 1 and 4. So that was a quick look at domain and range. Remember, domain is the things we can put into a function, range are the things we can get out of a function given the domain. And we've looked at how we can find them using the algebraic method, but also by using a graph to find both the domain and the range.